First up, we've got David Campey, and he'll be talking about realizing robotic dreams. So very excited about that. David.
Okay, thank you very much. Let's rock and roll. Okay, so my first question for the room is to wake us all up. It's somewhere in the beginning of day 2 or 3, wherever we are muddling around, and we've got lots of information swimming through our brains, but today we're to talk about robots. So my question for you folks is, did you ever dream about making a robot? Yeah, we got 1 or 2 hands? You know, and when did it start? Somewhere little. So I saw some chuckles and some laughs. Does anybody want to just like, what would your robot have done?
I don't even know.
We don't know anymore. What would your robot have done in the front?
What would it have done, or when did I imagine building one?
Yes.
When I imagined building one was the first time I saw one.
Which was when? Yeah. So you were probably somewhere around this big, yeah? Yeah. To have it move by itself and do stuff. Yeah.
I've wanted to build robots and things since before I can remember, and my robots would do whatever I needed them to.
This is really interesting. So, and then I think, did anybody not feel a sparkle of putting up your hand for wanting to build a robot? And if so, why are you here? And no, I'm not being. I'm interested because I think we've all seen robots. They spark us. We see what happens, and then we think, like, I'd like to do it. And we've got this dream engine inside of us that comes up with dreams, and it's like a pull-based system. We need to keep the dreams coming out of it. We don't have to do anything with them. That's the magic thing about a dream engine. We just have to acknowledge them and they'll keep going. But sometimes we just keep those top 5 around and the dream engine starts to shut down. So hopefully I'll help today to rekindle your dream engine and then give us something to do about it. Are you going to work? Yeah. So I'm David. Hello, PyCon Africa. And I've been at AfroLabs and Code Level Up. I'm now at CapTech, which is news to many folks because I started last week. And the thing that I do is creating the world we want to live in. And the way we do that is by making our dreams come true repeatedly at scale. And finding opportunities to scale that is really interesting to me. So I've helped build over 100 startups trying to make dreams come true. I've helped start 400 code clubs across the Western and Eastern Cape, giving space for young people to get opportunities that I had as a kid to just be in contact with code. And what I've come to do now is to dream about robots in communities, because it takes communities to build robots, and then robots build communities. And for me, how humanity and technology co-create each other. Humanity is almost defined by being something that creates technology. If we look at what we started with, the fire, language, all of these things that we do, those are our technologies. And so sometimes we other ourselves from that technology, but that core humanity and technology dancing together is the thing we need to do. And how do we do it? So we had a dream of a Meccano robot solving all of your problems here. It's like, honestly, like dreaming big, that's a big dream. The problem sometimes with big dreams, and Sheena talked in the previous session about the loop of joy, is that sometimes we don't get from the dream through the to the struggle to seeing something working. So that's the loop of joy that we'll go through. But we need to dream big and start small. And we're like, okay, I'll start small. And then we don't actually start. So today I'm going to take us through that cycle of dream big, start small, and start. Under dream big, I'll give some examples of things that I've dreaming big about still and that I've got going, ways to start small, and also a little bit philosophical about the theory of creating a creative learning environment for ourselves, and then give you some options on where to start. So in terms of dreaming big, we talked about robots, we talked about things, but this is kind of the reality of programming, right? I don't know if many people know this quote. I'll give you guys a moment to read it and chuckle about it yourselves, right? And it's a Reddit thing, right? And sarcasm breeds, and it just saps our our awesomeness and the desire. It's like, yeah, totally. We do these things not because they're easy, but because we thought they were going to be easy, right? And what happens then is our alignment of our intention vector and our action vector don't align, and that internal incoherence doesn't create energy. When they line up, when we thought it was going to be hard and it's hard, well, that's fantastic, excuse my language. But if we thought it was going to be easy and then it was hard, then we get sarcastic and we take our vibes out on Reddit. So I'm offering a slightly different thing. A dream maker's credo is that we do these things not because they're easy, because they're awesome, right? There's something we want to do. Those dreams, why did you have that dream? Because it would be awesome. Like, what is awesome? Awesome is a coherence between what's possible and what actually happens. That manifests in creativity. So how can we find that again and reconnect with it? And for me, also in my work with 7 to 17-year-olds, how can we get that to actually happen at a young age, that we get the idea we can start to do that and experiment early? And in my work with adult developers, how do we reconnect to that? I don't know if anybody knows Kid President. I think we all need a pep talk. Some of this talk today is a pep talk, but I don't want you to go out of here motivated to do something big and ambitious, because I'll come back and I'll see you next year and nothing will have happened, right? And no shade on anyone in the room. That's the way things happen, right? I'm going to take this off because it's getting a bit hot. So instead, I'm going to be offering a toolkit, and a toolkit to get things done and the way we can get there. But to start with, we need to choose what would be awesome. I'm just going to, a show of hands, has anyone heard of the psychological concept of a glimmer? Okay, no hands. Has anyone heard about a trigger? I was triggered, you know? That's become like popular culture, right? So glimmer is the opposite of a trigger, right? When we're triggered, the negative feedback cycle comes in, the anger, the hate, the disparity between what is and what we would like to be. A glimmer is the same thing, but for positive stuff. Oh, wow, that would be cool. That would be amazing. Our mechanism is 10x amplifying our triggers at all times, because that keeps us alive, and we need to work to keep our glimmers alive. And if we find something that will be awesome, it meets our actual needs. Our needs for coherence, our needs for creation, and those are needs we have. And when we meet our own needs and the needs of others, it increases the amount of joy available to us on a daily basis. This is the work of Marshall Rosenberg in nonviolent communication, which is this idea of how can we make life more wonderful for everyone. That, if you take a note on that, that is something you can spend years trying to master. But I promise to kindle your dream engine a little bit. So my robotic dreams go from rovers to Raspberry Pis on the International Space Station, to Raspberry Pis on massive blimps, to Raspberry Pis underwater. The Raspberry Pi is a platform that I've experimented with quite a bit. For the last few years, I've been funded by the Raspberry Pi Foundation. Thank you very much, to help us grow code clubs in South Africa. And they just make hacking easy, but I don't have shade for the other things. But in terms of dream big and how it started and how I got into that, it started at PyCon ZA for me in the large. I had not really built robots like everyone else who's dreamed about them. But then I met Sam. That's Sam 13 years ago, who'd come to my office after a PyCon because he needed help with Python. So this is the small start. Today we have over 400 clubs in the Cape, over 1,000 clubs in South Africa, and tens of thousands of young people every week taking part in that. Now, of course, there's survivorship bias to the story. Many of us, myself included, tried to do this over and over again before that one little thing happened where I found that connecting with a young person gave me 2 delightful hours and he brought his friends, and then suddenly we joined a global movement and suddenly that happened. But there was a dream of how could we do it? And we'd spoken about it, the previous PyCon, the next one, Flipbit, how we were developing it. So we just kept that dream alive and kept iterating. Another one, that's a huge dream that surprisingly came true, is this one, which I'm going to have to do the AV shimmy shammy for everybody. Give me a second. Where's that screen now? There it is. So the start of this video, and the audio of this video is not important, so I'll speak us through it, was an airplane. this robot came from South Africa and landed in Houston this year. This was one of the 3 robotics teams of high schoolers that took part in the World Championships in Houston. This team here, this is actually a sad video of theirs because they went hoping to win again because they won last year. They were last year's world champions. You know, back-to-back world champions doesn't happen all the time. But this is them training with teams from around the world. And the dream doesn't really get bigger than this. That robot is amazing at this scale, what they were doing. This is downtown Houston. The top floor is Lego, the middle floor is these microwave-sized robots, the bottom floor is washing machine-sized robots. It's 7 fields along, 20,000 people cheering. They had the baseball guys there shooting t-shirt cannons into the audience. Awesome, awesome robotics. And this is a massive dream that by the end of this, you'll know how you can take part in. I wanted to show about a minute of that, and I have. So now we're going to see if I can get my presentation back. Okay, so I'm just going to have to jump back and forth. Sorry for the recaps, but spaced repetition is good for learning. So another big dream is the Mars yard. So if you saw my talk last year, this is my magic trick moment where I reach into the bag and pull out a Mars rover. That's here, tangled in a whole bunch of cables. This is the HDMI cable that lets you see what's happening in the onboard Raspberry Pi. There's the rover. It's pretty robust against kids and stuff, so I'm not too worried about it falling off there. It's not robust enough to go to Mars. It's not a real Mars rover for anybody who asks. I get that question more often from kids than from adults, but we never know. And then we add a little mast on its head. It captures your imagination because it looks like the Mars rover. We have created, now this is going to do its little shimmy again. So this is me, I'm showing you me, talking about my stuff. But this is a YouTube video which I think is important to know exists because you can catch up on this afterwards.
Welcome back to the yard. So what we're going to have a look at today.
Can you hear that off the mic?
How, using this simulator over here, we can run a square, the code to drive the rover in a square, and how that actually runs in the real yard using the same code. So the code looks like this. We're going to go forward, sleep, and stop for our forward edges, right, sleep, and stop for our turning right, and we're going to combine that all in a square. If you've ever used Turtle in Logo or in Python Turtle, that's kind of one of the first things we do. It's quite fun. You could even do it in Scratch, the pen module. Going to make a square. And the way I figured out how long these edges are is by recording videos of it moving around. So we have the rover in the yard. I made it turn, and I opened it up in my video editor, and I timed how long those segments were to get a good idea. Nothing's precise, as we will see. So we're going to take this code. The first thing I'm going to do is I'm going to run that, start that running in the simulator. So let's pull that up, and boom, our simulator is starting to go. So here is our little rover moving in the simulator. It's going to get its first edge done, and then it's going to turn.
So this is a Tickle TK simulator that you can run on your laptop now, clone the repo and get it going. And I invite anyone who wants to come to my open space later and give it a shot.
So all I've done is change from importing rover simulator to importing rover, and I'm going to run that code in the yard. You can see that starts to move up there. If I have a look at the yard cam, off goes our rover. And if we look at them both together, we can see that the rover is heading off that way. It's actually rotated 90 degrees in the view. So that rover that's turned right is going down there, and the simulated rover, but they're both following the same code, trying to draw a square. It is an imprecise art. If you watch the rover spinning there, it's a lot of friction, a lot of slip to turn in reality. And even in the simulator, maybe off by about a degree when I end. But it's super exciting because if you were to run code in that simulator at home, which you can by cloning the repos, then you can send it to me.
So my invitation is out to all the clubs and folks around the world to run their code in the simulator, send it, I run it in the yard and send it back. These are geologically significant rocks from UWC, so every time you take a picture of a rock with the onboard camera, you get PDFs and data on the rock, and so you can geek out on rocks, and I get young people asking how rocks are made, and it's great because my co-founder on this, which we call Sapient Rocks, the South African Planetary Institute for Exploring Nature with Technology. It's a great acronym, and we have the domain name sapient.rocks. And I don't know what that is, so that's a word from not our sponsors. Go away! I shall taunt you a second time. Okay, so get a mouse cursor, and I need to do this reboot. What I'm going to do is I'm just going to bring this over and not do the whole I'm presenting on a separate screen thing, and then hopefully that. I don't even know what's going on. Okay, but you can see my screen. Oh, and we tried to play the embedded YouTube video properly. So there is an inbuilt camera on the mouse cam. There is a satellite view which are on another Raspberry Pi. There is an art installation museum exhibit coming up at the Cape Town Science Centre for their 25th anniversary. If you want to get involved in that, please hit me up. We need people to help, to tinker. That is a web user interface with block-based stuff I put together with Blockly so that smelly fingers in the science center can come and put their sweetie streaks up and down the screen and make the rover move and then run outside to see it move with a little delay to pretend you sent your signal off to Mars. So that's quite fun. This switching back and forth is getting me a bit behind schedule. So another big dream, which you will have heard of last year if you were at my talk, and if you haven't, LoCO AUV in partnership with the IRV lab in Minnesota. So the IRV lab is the Interactive Robot Vision Lab. We've done a series of community builds based at the Menzies Design Lab at UCT in Cape Town. And Moketsi is from the Ocean Hub, Yusuf is from UCT, and they're kind of the anchors of getting this project to happen. And they've really just pulled through in a big way. I've got 2 quick Instagrams to pop up on that. No, thank you, I don't want to not post for myself, but so let's get some. No, play. So this was our first community build after the features arrived, so dreaming big and starting small. This was particularly full of frustration, having to hand tool 3D printed parts, post-process them, get them together, find out things weren't working. But in terms of how to bring a robot dream to life, getting people together, making stuff together, having really shiny pressure vessels with cool machine stuff arrive, and then laying out all the parts on the table iteratively. So we're like, okay, that's what we need. That doesn't connect to that because we don't have that part yet, but these are our pressure vessels. We're going to be really cool. That's what really kept us going, got us going. And then, so what's in it for me, for someone like Moketsi, is he works at the Ocean Hub. For me, it lets me nerd out. For Yusuf, on the other hand, he runs the Menzies lab, and they've got a list of projects they do. Now they can add a LoCO AUV to their list of projects. So we always need to connect it to what's going to actually make it work for us and keep it going. So then this was a week ago. This has slowly been emerging. So let's see if I can do that magical switch to zoom as well, and I'll give you play. There we go. So you can see the Mars rovers on the table because like we play with all sorts of different robots at the builds. Those are the penetrators going through the end cap. They just look so shiny. We had some students come in, first year students. This is a postmaster's student who works at the African Robotics unit, Emmanuel, who's been really pulling through to get some of the components working. This is a hard robot, right? And I would not expect everybody to sort of make this in their garage. I wouldn't expect this to happen with a school teacher in some place. But this hard robot has a full gazebo simulator, so you can run it on your desktop in an Ubuntu VM and watch the robot going around, send code to Moketsi, who will then run it, and when this robot goes underwater at the aquarium with the divers, your code can run on it, and we like a sequence of code to run on it. So that's another way that we can start to jump in. That is a picture of a motor turning. It looks really cool. It's synchronized with the music. Also, it should be turning a lot faster because the stator and the rotor didn't actually match. And this comes from using an open source project from 2019, and the part has come out of date in the physical world, so we're waiting for a new one. That's a picture of the original build, and these are the folks who are involved in that. So really, this is the dream big part that's supposed to get us going. Was that 10 minutes left? Okay, so I need a mouse cursor, please. Come on, do this. Thank you. Okay, so that's the LoCO. But as I said, dream big and start small. But what can we do today? Come to my open space. What can we do where we can play with robots? What can you do tomorrow when you get home? So the start small on the LoCO was there, re-invitation there, but this is the philosophical bit, or the learning theory, a creative learning environment. There's a free open course at MIT called Learning Creative Learning that you can do, which has as one of its principles the idea that when we create a learning environment, we need a low floor. It needs to be easy to get in, but we want a high ceiling so it doesn't get boring. It's like we don't want to just do Duplo because that's got a low floor, but luckily Duplo bricks can connect to Lego bricks, and Lego bricks can connect to motors, and then you can like glue stuff onto them and use the Kaggle, and then stuff happens. And then we want wide walls because we all have different passions. So I've been through a collection of projects. I've been showing you how we find peers in our work, and that is the key thing for me, is the process of finding peers, shopping it around till you find someone who's going to take your glimmer, feed it back to you, keep it going, because these things are hard. And then we need to find a way to play and find our passions. So firstly, I just wanted to say thanks to the people. So at the Code Club side, Sonia was my first contact when it was still called Code Dojo. It's now all called Code Club. Annalisa is our Code Club growth community manager in the Western Cape. She's trained over 500 teachers now and helped us start clubs. Warrior was the global partnerships lead for the Raspberry Pi Foundation, who handed over to Anna. Rachel's the MD of the foundation, and Nangamso is our new Raspberry Pi Foundation country lead. All of those helped that Code Club dream to come true. The rover, Matthew, my co-creator, we were both dads at our Code Club, and it turned out he liked planetary science, and I'm a bit of a space nerd as well, and thinking about meteors crashing into the Earth, and he brought me a rock, and I had a rover, and we were like, wouldn't it be cool for that rover to look at that rock? And we ran an event at UWC where we put the rover in the rock, and he gave me a Mars bar as a prize for getting the rover around the rock. And these are the fun things that make it come alive. And he had a friend in Europe who runs the actual big Mars yard they use for the European Challenge, Anya. And then Richard at Parklands College offered us an unused makerspace at their school that they were busy repurposing to run my yard from. And then Paul is the head of innovation at the high school, who came down to the primary school where my classroom was, and he was then the head there, and he supported it by introducing us to teachers. And Pam runs CosmoQuest X, which is like with the Planetary Science Institute in the States, and she's helping us think about how we raise money. I mean, these are the people that make this thing come alive and make it possible. The LoCO AUV I've mentioned, Alexi is the founder of the hub. So I came to him and I said, how would I raise money for this robot? It's $4,000 of parts, right? That's a small car. And he said, well, I don't know, we don't have funding, but I can think about fundraising. That would be cool to do with a hub. I then met with him again. He said, actually, Dave, we got that money from Eric Schmidt, and 10% of that was supposed to go to hardware. We don't have a hardware project, so let's do it. So thanks to them, and then he seconded McKetsy to help with the project, and that's made it work. Yusuf at the Menzies Design Lab was like, we need cool projects, we need to get students in here. And then Emmanuel has showed up, and so has Garth, as community members, and that people have really pulled through, and it's like, crap, I can't do this work right now. They're like, oh, I'll do it. I said, oh, wow, you can pick up and resonate. And from the first tech challenge, Michelle and Ethan from Team TechSpan, my wife started a robotics club at her community center in Delft, inspired by TechSpan and sponsored by their process of, after having become world champions, they got funding, and that club finished 12th in South Africa, and my daughter was able to be a junior member in that team, and then because of that she got selected to the team that was going to internationals, and I was able to go to Houston. So I think I have my daughter to thank a lot for geeking out on FTC, and I was very angry with her about FTC for a lot of times because it was like bedtime, other things to do, I wanted to do stuff, and we all this FTC stuff, but I'm so grateful. And sometimes we just need to push each other and pull each other, and that's really great. So when we need to play, we've talked about the loop of joy, having an idea, we move the struggle, and seeing it working. This kicks, you might have heard of dopamine. I prefer to call it dopamine, right? Because gambling gives us dopamine because we're not sure of the outcome. Right? Sports watching gives us dopamine because we're not sure of the outcome. If we're sure of the outcome, there's no struggle, there's no uncertainty, and there's no massive joy when we see it working. So the more we struggle, the more we play with it, the more actually we reward ourselves with energy, and energy management is the core game for software developers. So if you're a software developer manager, encouraging people to take part in stuff like this will make them come alive like this, even though they work at regular software day jobs. And that's super amazing, because when we have that side passion project to kind of do stuff with, meet other people, share ideas, we'll talk about how do we test, how do we do things, and that builds community. And as I said, robots build communities. So how can we start? Wide rules. So the projects I've showed you today give you wide rules. Are you passionate about space? Great. Well, take that QR code, and you can get that YouTube video, which has a link to the GitHub repo, and you can come afterwards. Are you passionate about rocks and like impact craters? You saw my meteor talk yesterday. Then you can also get involved in this, because we've got the people who actually make the XRF and the libs coming to the yard. Those are the instruments that are on the Curiosity rover to come and actually scan these rocks for us with a handheld scanner and give us the same data that Curiosity gets on Mars. Because that's just awesome, right? The LoCO AUV, there's lots you can do, even if you're remote, even if you're going back to somewhere in Africa. That would be the biggest gift you could give to me, is sending me working ROS code with your simulator. Navigate the real world. So I see it having a huge space, and when we deal with 17-year-olds, there's one thing, but that robot also, when we asked the African Robotics unit for help, they were like, great, but can we also use this for our master's capstone projects? It's like, well, of course, it is a robot designed for research, so we should be seeing really interesting research tasks happening with it. Thanks for a good question.
I guess I actually have a quick follow-up question on that. Like your point about the like the sort of importance of the struggle for learning kind of resonated, and I was wondering like what your thoughts are on sort of managing LLMs in learning, and that it becomes quite easy to sort of offload some of that struggle to the LLM.
So the struggle is real, right? And it's going to get hard. We can speed up the rate at which we're going to run into the wall. And as Ashina said earlier, like maybe we want to take smaller steps, so we haven't developed as much velocity before we hit into the wall. We might want to take on smaller tasks first. But also, like, I wanted to take part in that, in a robot thing. I one-shotted getting my robot to be able to spin. Because it's like, I don't want to work out that maths. Could you do it? Boing. Run. Hey, it spun on the spot. It was awesome. I didn't have to figure out the maths today. And then when I wanted to debug it later, I had to figure it out. And luckily, I had good maths that I could Google. But yeah, so for me, like, the struggle will come. I don't think it's our job to try to remove the struggle, as long as we can have creative learning environments. As long as we're not trying to be instructive and say, you need to learn this. Well, I can show you I can do that. But when I get to creative learning, I'm like, oh, well, could I make that thing move that way? I don't know how. Okay, now I need to actually find how to even think about that. And creative learning is going to be hard enough that anything that helps get going faster is great. And when people go backwards and learn those skills, I find they're like, oh, this sucks, I don't get it. Then you go, and when they sit, you'll find a 12-year-old sitting with a Python textbook reading through everything. They're like, oh, I knew what all that was, but now the thoughts fill in. And the thing for me is most education stuff that I find online tries to go too fast. I've showed you a for loop. Great, so now we're going to do for loops with, no. How many times did you draw a house when you were 5 years old, or 4 years old, or 3 years? And how many times were your parents happy to see the house? It's just a square with a triangle on top. So when the kids used to come to my first dojo, I'd be like, let's use Python turtle, draw a square, draw a triangle, make a house. I didn't teach them to save that file. They came back the next time like, let's draw the little house again. They were not disappointed that they were drawing the house again. And the number of times they did that until I said, oh, did you know there's something called a for loop that can simplify this code? And they're like, did you know you can save? Like, oh, that's cool. Don't know that in the beginning, and then we've done it so many times that, like playing chess, even though we know the moves, you actually need to rewire the brain. I think the point about a calculator, for example, we have calculators, but we need to learn numbers so that we have this concept of numeracy. I failed first year maths 4 times because I'd done maths and it was easy, so I was like a kid using an LM until it got hard. And then I needed to rewire my brain. And then I actually needed to practice, and I didn't know how to do that. So it's a skill we need to get into, and I tell young people, like, do the work, get the marks. But you need to figure out how to get them to not do work they don't understand. So that's a hard problem. I don't know how to solve it entirely, but there is an internal quest for that struggle. That's art often, yeah. That's creative learning.
That's fantastic. Okay,
have you found that the sort of hardware that you can get within a small robot, like, and obviously using a Raspberry Pi, has sort of expanded what you can do? Because I'm sure like a big part of the problem is getting enough compute on the machine.
Yeah. So you asked about a small robot. So that's a robot platform that a microbit can go on. Microbit can do basic tasks and a bunch of things, but in terms of what you can put on there, you can do a lot of sensing with the sensors. It's extensible. You can add other things onto it, like this bolt-on arm that's in here. The things that we can do on small robots these days allow us to explore the problem space a lot. If you look at a medium-sized robot like the LoCO, it has one Raspberry Pi brain and one Video Jetson TPU, well, these days we call them other things, but it's the Nano, and that's used for the vision tasks. So getting compute onto the edge is interesting, but actually most of the stuff that we do, there used to be a machine learning joke about 5 PyCons ago about most machine learning is just a less than or greater than sign. You know, most of this environmental navigation is just a less than or greater than sign. Yeah.
great. I think let's give another round of applause for David. That was super inspiring. Thanks.